Hello everyone. Now we are going to discuss about a service mesh. This is the concept we are using in Kubernetes. Let's see what are the topics we are going to discuss and cover in this video. What is service mesh, why we need this, features and how does this work, and the architecture, pros and cons of service mesh, when to use, and the service discovery and service registry. So the service mesh is an infrastructure layer to communicate and service to service. It's focusing on managing all service to service communication within a distributed software system. This makes communication optimization easier, and it is a way to control how different parts of application shares the data among themselves. A service mesh usually uses a group of network proxy that are set up next to the main service, and the main service does not need to know about this process, and it's for cloud native application. Why we need service mesh? Because a microservice architecture grow more complex, managing communication between service become increasingly difficult. That's why we need a service mesh. Without a service mesh, each microservice must individually handle network traffic, security, and fault tolerance, which complicates the application code. A service mesh reduces this complexity by centralizing communication management and improve the observability, enhance security, and optimize the traffic flow. This centralized approach simplifies inter-service communication, leading to more scalable, secure, and maintainable application. What are the features of service mesh? Um, the first one is traffic management. It's include a load balancing, routing, and flyover to ensure that the traffic is routed optimized between the services. Security provides encryption, authorization, and authentication for securing service-to-service communication. Observability collects metrics, logs, and traces, offering insights into how services are performing and interacting with each others. Resilience implements circuit breaking and timeouts to ensure the application is fault tolerant and can recover from failures. The last one is policy enforcement. This configure rules and policy for routing security and traffic control, ensuring compliance with defined standards. So let's see how the service mesh works. A web proxy operates in a sequential process. The user computer sends a request to access resource via internet. Instead of going directly to the web server, the request is routed through a web proxy server. The web proxy acting as an intermediary forward the request to intent web server. The web server receives the request from the proxy, process it, and prepare the request data for a web page. The web server sends all response back to the proxy server instead of directly to the computer server. The web proxy then sends the received data from the web server back to the user computer, completing the interaction. These step-by-step process ensure that the proxy server manages the communication flow between a user and a web server. So this is architecture of service mesh. In this we have control panel, data plane, and sidecar proxy, instances, observe, and trace. So let's see one by one. So control panel. The control plane is responsible for managing overall service mesh. It handles a configuration, monitoring, and policy enforcement. User or administrator can interact with the control plane via a command line or API. The control plane message the sidecar proxy that run alongside the service and ensure the policy and configuration are consistently applied across all instances. The next one is data plane, that is east and west traffic. For example, we have a e-commerce platform. The user can log into the platform and he can check that one, and he can add to the cart, and he can payment. Then he can also notify the notification. So in the data plane, we have two types, that is ingress and egress. So if we expose the outside the Kubernetes cluster, the ingress is created for the login microservices. The traffic within the Kubernetes cluster is refers to a ingress traffic. The traffic comes from the outside refers to the ingress. The data plane is where the actual traffic between services occurs. In this diagram, there we have a three instance, that is instance A, instance B, and instance C. Each instance has a sidecar proxy associated with it. The sidecar proxy handles all the network traffics for a correspondent server's instance. It ensures that all the requests and response are managed according to the control planes rule, provide enhanced security, observability, and routing capabilities. The term east-west traffic refers to the communication that happens between a different services within the data center. Already have told that that east-west traffic is means um, ingress, egress, and the outside it we called as ingress. Mm, So sidecar proxy. Each service instance ABC has its own sidecar proxy that intercept communication both inbound and outbound traffics. These proxies handle tasks such as load balancing, service discovery, and returns, while also enforcing security policies such as a mutual TLS for encryption. So the let's see the interconnection communication. The green and blue arrow between the sidecar provides indicating that the communication between service instance ABC is managed by this proxy. The sidecar manage traffic between instance and ensure that any routing decision, secure measures, or observability tools are applied. So the next one is observability or tracing. On the right side, we have seen a box labeled observe and trace. This represents the monitoring and tracing functionality provided by the service mesh. The sidecar proxy collects the data on the traffic flow through them, which can send to monitoring system for observability. First, it sends to the observability um, to track service performance, or tracing to trace the path of an request through the multiple services. So the overall, so the CLI AP is used to interact with the control plane, where all the service configuration and policies are managed. The control plane manage the sidecar proxy attached to each service instance. Sidecar proxy handles all the communication east and west traffic between the service instance. Observability and tracings are enhanced by service mesh, as the sidecar proxy provide the metrics and tracing information. So the next is pros and cons of service mesh. So better visibility, improved security, traffic control, resilience, simplified service management, flexible deployments are the advantages of service mesh. Better visibility, you can easily see what's going on between services, making it easier to troubleshoot problem. Improve security, it encrypts traffic between servers, making communication more secure. Traffic control, it allow you to manage and control how service talks to each other, improving performance and reliability. Resilience, it can handle services failures gracefully by retrying or rerouting traffic, making your system more reliable. Simplified service management, it takes care of complex communication tasks so developer can focus on building features. Flexible deployment, you can roll out all updates in stages. That's a canary or blue green deployment. reducing the risk of failure. So, disadvantages, it's a more complexity. While it simplifies some tasks, setting up and managing a service mesh can be complicated. Performance overhead, it add extra components sidecars to handle communication, which can slow down performance slightly. Higher cost, running a service mesh uses more resources like CPU and memory, increase optional cost, so may not be need for small apps. For smaller application, it might add unnecessary complexity if you don't have many services to manage. Other debugging, sometimes it can be tough to figure out whether issues are caused by the service mesh itself or the application. So a service mesh is useful for large system which many services, but it can add complexity over, especially for the small projects. So when to use a service mesh? For a large scale, large applications, and application required a fine grained securities and observability, teams that want to offload the responsibility of a network level concern security for developer to infrastructure. So the next is a service discovery. What is service discovery? Service discovery is the automatic dedication of service available on the network. In microservices architecture, new services are constantly being added or removed, and the service discovery ensures that the other service can find and communicate with this service without manually configuration. How it work on service mesh? It a service mesh, for example, is to linked. The service discovery process is handled by the control mesh. The mesh control plane maintains a dynamic register for available service and their endpoints and provide that information to the service that needs to communicate with each other. When a service want to talk to another service, it query the control plane which returns the service location. And it need a DNS based or envoy based service discovery mechanism can be used. So what are the benefits of service discovery? Dynamic automatic updates or service locations as services removed or added. Load balancing and L checks are typically built in. So let's say a simple example scenario for service discovery. So imagine you have a payment services and a shipping services. When the payment service finish processing, it needs to notify the shipping service to dispatch an item. Service discovery allow the payment service to automatically locate the shipping service endpoint even if the shipping service is on different instance or service. So what is service register? Service registry refers to the process where services announce their presence and capabilities to a central registry or a service directory. It ensures that the control plane know about all available services, can route traffic accordingly. How to use this? In a service mesh, services are typically automatically registered as part of the infrastructure. For example, Kubernetes. The mesh control plane monitors servers endpoints and automatically register them in a registry. They need to manually register. Manual register may not be required in many cases due to automatic integration, but you need to register. That's all about service mesh. Thank you.